Welcome everyone to Advent of Code with Pandas. This is day 13. So here's our input data. We're given pairs of lists. Our job is to compare the first item in the pair with the second item. We want to see if the first item is less than the second item. All right, so the rules for comparing the list are basically the same as Python's own built-in list, except for one little change. So the way Python compares lists is that it goes element by element like this, and in this example will not work actually because the third element is actually a list on the left side. So it's trying to compare 3, 10 with 3. That is impossible. So what I've done to solve this is created my own list class, so capital L list, which inherits from list. So whenever I'm doing a less than comparison, that's what this special method does. Whenever we do a less than operator, I'm going to say, hey, if it is an integer, so if we're comparing against an integer, actually do this operation instead. So self is just the current list. So say here 3, 10. It's going to force the other list or force the integer into a list. That's what the rules say. So if you have a list versus int comparison, you just convert the other one to a list. Same way for the greater than over here. All right, so let me go ahead and input this class, and I'm going to show you this same comparison over here. So now I've created them as my custom list class, which knows how to do comparisons between lists and integers. And now I'm going to compare A versus B. Is A less than B? No, it is false. So we have here, we're doing a comparison of 3, 10 versus 3. So what's happened is 3 has been changed to a list. So what's really happening is this comparison right here, and that is false. So the way the list comparison works, it does check 3 and 3, but then this one still has more items in it. So this is actually greater. It's considered greater than this list over here. All right, so we're going to use this list custom list class instead of the built-in list to do all the comparisons in Pandas. All right, so I'm going to go ahead and read this in. The first thing I do is read it in as a series, so I don't have any separator. X is just a, there's this capital X does not even appear, so I'll just read every line in one at a time so I can show you what it originally read it in. And this is as a string. So it reads everything in as a string. And then what I do is I create a data frame because I want to put every other value in one column and every other value in the right column. So I create 2 columns like this. Let me comment this out for now. Okay, so these are still strings. We have not converted them to lists yet, right? So, I'm just using this step of 2 in order to select every other one. And then what I'm going to do is pretty interesting. So I'm actually going to replace this bracket, this left bracket, with list of, this capital L list, parentheses, left bracket. So I'm actually going to replace that using a regular expression. And then I'm going to replace the ending bracket with a bracket and then a parenthesis. So let's just do that so I can show you this. So I've converted all of these. This is still just a string right now. And then what I'm going to do is I'm going to go through one by one and use the eval built-in function, which you have to be careful with because it just executes arbitrary code inside of strings. So you have to hope that nothing malicious is in here, or else it will get executed on your machine. So it's just going to execute this as if I typed it out like this over here. All right. And then the last thing is that the index in the problem begins at 1 and not at 0. Okay, so it looks like normal lists, but these are actually my custom lists like this. Now I can do the comparison. I can just actually use a query method. I can say, where is the left list less than the right lists? So there are 80 rows remaining, and the problem just simply wants us to get the index and sum up the index. So that's what I do here. I just sum up those indexes. So that's the part one. Part two is to sort all of the lists, but add in two sort of very short lists that are, I can just show you to them. So it says to add in these lists into these. There's 300 total lists, right? 150 rows, 2 columns. So add these 2 in here and then sort them. So what I've done is I'm just going to stack these lists all one on top of the other into a single column. And then I'm just going to call sort values like this. And then again, I need to get the index. So I need to get the current place of the index. So let me just go ahead and run this so you can see how it's sorted. So you can see here, it sorts everything like this. I do need to change the index. So I have to, after sorting, I have to drop it and then add 1 again to make it from 1 to 302 this time. So it can correctly sort. That's pretty cool like this. Now, you see here, this is merge sort. So it turns out that this rule right here isn't robust enough. So there are times when this will not work. Like if there's two very similar lists, it doesn't always work. It's not the most robust solution, but I still wanted to show you this solution just so you can kind of see a unique and different solution than many others. But it still gets the right answer if you put if you put those dividers on top. So these 2 that they've given to you. So your goal for this one is to find those dividers. So I'll just search for where they are in there. And n largest, there's only 2 that are true. Here are the index. So that's where they are. So if you want to see their place, you can see, like, use a loc. You can look at from 100 to 120. And so you'll see these. You can see here's that little divider that they say it's between, the beginning of 1s and 2s like that. 6 is in the same, looks very similar. And all we want to do again is take the indexes and this time just multiply them together to get our answer. All right, so some pretty interesting tricks here. This is probably a different solution than what you'll find elsewhere. It isn't completely robust. So this logic in here isn't going to cut it for, sorting every single possible combination in the right order. But it does work if you do place the dividers on top of all of them like this. All right, so that does it for Advent of Code with Pandas Day 13.